Hi everyone and hi all my followers. Here in this video I'm going to analyze the problem of reagents. So very important, just observe it. The appropriate reagents required for carrying out the following transformation are. So here we have given with benzyl alcohol as a reactant and which is converted to produce cinnamic acid. So we need to find correct reagent combinations from the given four options. Okay, if we apply the first reagent combinations, that is A, onto the benzyl alcohol, we need to check the products. Okay, right. We have given with PCC reagent, that is pyridinium chlorochromate in presence of dichloromethane as solvent in acidic conditions. Just remember that PCC, pyridinium chlorochromate, oxidize benzyl alcohols and allylic alcohols into their respective aldehydes. Okay, that's why here benzyl alcohol converted to benzaldehyde whenever it reacts with PCC, pyridinium chlorochromate. In the first step, that means if we check the mechanism, the lone pair of electrons on oxygen of benzaldehyde attack chromium and cleavage of chloride takes place and we can get this intermediate. Now the bond, that means carbon hydrogen bond, cleaves, bonded electrons goes in between carbon and oxygen, and in that case oxygen chromium bond cleaves and electrons goes on to chromium, and from that we can simply get benzaldehyde. Okay, right. Now benzaldehyde reacting with triphenyl phosphenic ester, just observe it, and the reaction with aldehyde carbonyl group and this kind of reagent simply Wittig reaction. Okay, we just observe Wittig reaction, and in that case triphenyl phosphorus and oxygen of that means aldehydes or ketones simply cleaves triphenyl phosphonates and we can get alkenic product. Okay, right. And in the next case, that means a combination we have given with aqueous NaOH on heating and followed by hydrolysis, we can get the cinnamic acid. That means in the first steps, in the presence of aqueous NaOH, that means ester cleaved to produce cinnamic acid, that means carboxylic acid group, by the elimination of ethanol. Okay, by the elimination of ethanol we can get the final product that as cinnamic acid. That means the first reagent combination is the correct reagent combination to produce cinnamic acid from the benzyl alcohol. Okay, now if we check the second reagent combination on benzyl alcohol, we have given with chromium trioxide, H2SO4, aqueous acetone. And if you look at this reagent combination, we call it as Jones reagent. Okay, and just remember that Jones reagent oxidize primary alcohols into aldehydes, and over oxidation is also possible with Jones reagent. That means aldehydes may also convert to produce carboxylic acid groups whenever the Jones reagent takes in water. Okay, just remember that whenever Jones reagent is taken without water, that means chromium trioxide, H2SO4 and acetone, it only limited to produce aldehyde. That means alcohol, primary alcohol converted to produce aldehyde only. Okay, right. Here whenever Jones reagent attack or oxidize secondary alcohol, it always produce keto product. Okay, now we have given with benzyl alcohol and Jones reagent combination with aqueous acetone. That means it contains water, so there is a possibility to produce benzaldehyde, and from that it may also produce benzoic acid. So whenever benzoic acid is possible, then this reagent combination is not the appropriate reagent combination to produce a cinnamic acid. But if we have given without water in Jones reagent, it may produce aldehyde, that is benzaldehyde, and we have given with reagent combination, that is sodium acetate and that means another in a hydride. So that simply Perkin's condensation takes place and that may produce cinnamic acid. But the option B is not the correct reagent combination to produce cinnamic acid, because in the first reagent, that is Jones reagent, we have given with aqueous solution of acetone. That means over-oxidation takes place and benzyl alcohol converted to carboxylic acid group, and the further reaction is not going to produce cinnamic acid. So here we can eliminate option B. Okay, now if you look at the third one, we are reacting with manganese dioxide, benzyl alcohol produces benzaldehyde. Okay, just remember that manganese oxide is a well-known reagent to oxidize allylic and benzylic alcohols into their respective keto or aldehyde products. Okay, now benzaldehyde reacting with another reagent combination we have given with, that is we have given with CH2CO2H taken twice, and piperidine and pyridine. As we know, pyridine is a strong acting as a base, strong base here, and it can abstract proton from that CH2, and here is a formation of carbon ion, and it can attack on aldehyde, and this kind of reaction is simply considered as knovolangel reaction. Okay, right. In the next step, piperidine containing hydrogen on the nitrogen. Okay, just observe it. This is piperidine, and here it can donate proton for that O minus, and we can get alcohol here. Now piperidine is acting as a base here. After donating its proton, it is acting as base, and it can abstract proton from that central carbon in between the two oxygen groups of two carbons. Okay, just observe it clearly. Now here is a formation of enolate type intermediate, and then further the negative charge on oxygen goes into the carbon, then double bond goes here, and OH minus cleaves from it. Then we can get another intermediate here, then possibility to cleave CO2, and that means here just like this, and cleave CO2 cleaves here, and we can get cinnamic acid. That means the third statement or third reagent combination is also producing cinnamic acid. That's why the third reagent combination is also correct one. So here A is a correct reagent combination, C is the correct reagent combination, B is the false reagent combination. Now we need to check for the fourth one. Whenever we are reacting benzyl alcohol reacting with PCC CH2Cl, as we discussed in the first reagent combination, it produces benzaldehyde. Yeah, here we have given with another reagent combination, that is zinc and alpha bromo ester, and whenever we see this kind of reagent combination, there is a possibility of reformatsky reaction and the involvement of 6-member type of ring here, intermediates. Okay, just observe here that means observe the arrows, and we can get this intermediate, and further hydrolysis, cleavage of that oxygen zinc interactions, and we can get OH group here, and further heating, simply elimination of water from the two carbons here, and we can get a cinnamic acid again. That means from all these analysis reagent combinations, option A, and that means A reagent combination, C reagent combination, D reagent combinations are producing cinnamic acids from the benzyl alcohol. That's why they are the correct reagent combinations. Okay, right. Now if you are interested, please visit chemmasters.online website, and you can join on courses like CSIR, GATE and JAM chemistry, and you can get all the syllabus type of all the syllabus wise concept videos with best analysis, and also you can get previous year solved problems as in the form of videos, and you can get assignments also. Okay, they are very helpful to you. Get the courses on chemmasters.online, and you can also download mobile app from Google Play Store. Okay, from Google Play Store, and you can get sample videos from that app, Chemmasters. Okay, right. Thank you.